to Mariah, are we good? Okay. We are about a week and a half away from the first unit test in AP Calculus. That probably fills you with some strong feelings. Maybe you're really excited. Maybe it makes you want to throw up. I'm not sure, but we have the next 7 days to continue learning new things and see where we go with this. Okay? Where we started the unit, we were looking at limits and all the different ways to work with limits, and for the last week it's been applications. What I want to do is we're going to really start this next leg of your calculus adventure by talking about slope of the tangent line. This is something that you talked a little bit about last year with Mr. S at the end of pre-calculus. I'm excited we are coming up on the end of things you already know about. Okay? I don't want to go so fast that I lose you, but I also know you've had some exposure to this stuff previously. Okay? Here's what you need. You're going to need some markers or colored pens, especially for those of you that are like color coordinated. You want this thing. There are rulers in the supply kit. These are rulers. They are not propellers. They are not samurai swords. They are not ninja blades of death. It's a ruler. Just a ruler. I'll tell you, today is also going to be really heavy with some vocabulary, so just sort of make room in your heart for the vocabulary. I've added some more stuff onto the vocab wall. Somehow, no matter how much I increase the font size, it's not big enough for those of you that sit in the wrong part of the room. But you can always go on over and check it out if you need to, but you probably can't see it from where you are. David, you may not even know that it exists from where you are. I'm working on it. Okay, so here's what I want you to do. I want you to take out your ruler. Oh, so awkward. So awkward. And I would like for you to draw a tangent line at the point x equals 4. We're going to start the conversation there. Can somebody remind me, what does it mean to be a tangent line? Jose remembers what it means to be a tangent line. Ramir remembers what it means to be a tangent line. I say tangent line. Jasmine, what does it mean to be a tangent line?
It only touches the graph at one point.
It.
The line.
The line touches the graph one time. So draw for me, please, a tangent line at x equals 4. Tangent line at x equals 4. Tangent lines touch once. It is important that your line is not going through the curve. Your line is touching the curve. It's always so interesting to see what happens with teenagers and their rulers. So if I take a ruler, I'm over here at x equals 4. Somehow I've lost my marker. Here's x equals 4. Your line needs to be just touching the curve at x equals 4. Yes, that's what I mean by a tangent line. What kind of line?
A tangent.
This is a tangent line. Specifically, we're at x equals 4. The point x equals 4 is what we're going to call the point of tangency. It is the point at which the tangent line touches the curve. So we've already got some new vocab coming in here. We've got tangent line, and we have point of tangency. All right. So far, so good. Now, Sir Isaac Newton, right? You may remember him from physics. Last time we saw him, he was sitting under the apple tree. The apple falls down, bonks him on the head. Boom, we have gravity. That's not quite what happened, but that's the guy. Isaac Newton said, you know what? I'm really interested in slope of tangent, which I'm just going to write as tan. Say it with me. Tan. I want the slope of the tangent line. I want the slope of the tangent line at x equals 4. That vertical bar means at. If I want the slope of the tangent line at x equals 4, there's a problem here. You guys have been finding slopes since 8th grade, maybe? 8th grade, maybe it was 9th grade when you first learned about slope. Somebody remind me, how do you find slope?
Rise.
You know this from here, how do you find slope?
Rise over run.
You find slope by doing rise over run, but the problem is this. If I want the slope of this line, what I need is another point. And this line touches the graph how many times? One time. My goal, I want slope of tangent line, but in order for me to do that, what we're going to do is we're going to pick another point. And I'm going to label that point x comma f of x. I want you to pick this other point anywhere that you'd like, but I want you to connect it so that my line connects this point here with the point of tangency. Okay. I definitely want to go slow enough that you can get a good graph going. Still a tangent line? No. Oh. Just a little bit wrong. Just a little. Eunice, what do you think? Still a tangent line?
No.
Why not?
It touches the graph 2 times.
Because this line over here is touching the graph twice, right? If the line touches the graph twice, we're not going to call it a tangent line, we're going to call it a secant line. Okay. Finding the slope of a secant line marked here should be a very easy thing for you to do. Because you know you've got this point over here at x equals 4. And the coordinates here I'm just going to label as 4 comma f of 4. And you've got this point over here that I'm just going to label x comma f of x. And you guys have been finding slope forever and ever and ever and ever and ever, right? Slope is rise over run, I heard. Slope is change in y over change in x. Slope is y2 minus y1. If I just said go find the slope of the secant, we would find f of x minus f of 4 over x minus 4. And that's going to be secant. What is that? Secant. David, do you want secant? No. What is it that we are really after here? What I want, Edgar, one more time. I know, you were built for lessons like this. Tan. Daddy wants some tan. I want slope of tangent line. But the problem is a tangent line involves just one point. So what you do, what Newton said is, you know what? I'm going to pick another point on the curve. And the other point on the curve, I'm going to find the slope of the secant line, and I'm going to use that to estimate the slope of the tangent line. Big picture, are we okay? Turn to somebody near you, explain to them what's going on. This is where I lost people last time. Take us through the story.
This is secant estimate. This one.
So Edgar, what's the goal here? What is it that we're trying to find? I mean, yeah, Edgar. Sorry, even though I was looking at Abraham. Edgar, go for it.
The slope of secant in order to estimate.
But what we want is
Tan.
tan. You want tan. But Noemi, what's the problem with finding the slope of tangent line? Why can't you just find it? In order to find the slope of a tangent line, you need 2 points. What's the challenge? If we're going to say this is the slope of a tangent line, the challenge is
There's no second point.
there's no second point. I have 1 point. So the solution, Jennifer, what do? What you're going to do is you're going to pick another point. You're going to form a secant line, you okay? And we're going to find the slope of the secant. Now I'm curious, how do we feel about this secant line being used to estimate the slope of the tangent? Like good?
No.
I hope not. This is a horrible estimate. Can somebody make it better? How could you make a better estimate? This is the conversation for us to have. Christian, how would you make the estimate better? I hear you say get the line closer to the tangent. I like that. But the way that we're going to do that is we're not going to really change the line. What we're going to change is the point, that second point. How about if we did that point? And so like draw another line. Okay, I'm doing it because I don't have a ruler big enough. That secant line, I'm going to call that secant line number 2, is closer in slope to the slope of the tangent line.
No.
It's closer in terms of the slope. It is closer. It is a better estimate. But if that's a better estimate, what are we really going to do? Find an even better estimate. Jose, how are you going to find an even better estimate? So move the point closer. Make another secant line. So I'm going to call that like secant line number 3. Secant line number 3 is closer in slope to the slope of the tangent line. Everybody mostly okay? See, right? And you might say, well, coach, that's good. That's a good point. That's close. But guess what? I can get closer. Right? I can get closer. How close can I get?
Pretty close.
Like pretty close?
Get on
Like
this.
really close? Prom date close? Inappropriate
Not a yes
close?
pro.
Close. I'm not even sure what that means, Edgar. To find the slope of the tangent line, here's what I want you to do. You're going to find f of x minus f of 4 over x minus 4. But that's not slope of tangent line. This is secant. The way that I'm going to form slope of tangent line, I'm going to move this point closer and closer and closer. Closer, so close to x equals 4 that you know what?
It touches.
Not that it touches. They are so close, you can't tell the difference between them anymore. That is so, it is limit close. So we've got slope of secant, but if you say let that point get super close to 4, get limit close to 4, that's how you find the slope of tangent line. So the thing I want to make sure you've got in your notes, the slope of the tangent line at x equals 4 is going to be the limit as x approaches 4 of f of x minus f of 4 over x minus 4. You might want to put a great big bar or a bubble or something around that to make it really clear. I will tell you, I care greatly about your being able to come up with that formula on your own. And I want to give you another minute to just talk this out with somebody near you. I want to hear the words come out of your mouth. Like, how do you come up with this? What are we doing? Go for it.
Mr. D, can you come here? Can they still see? Or is it kind of too far? Like, will it look different?
I think it'll be okay. I think it'll be okay. They can zoom in if I have to. 4, 6, 9, 13, 21.
Where?
That's zooming up next. There is not nearly enough productive math conversation going on right now. Okay. Robert.
I know, but for the limit part, you plug in the limit or you solve the equation first. Yeah, but then you plug in the limit.
Okay. All right, let's do this. We can put away the rulers. You don't need them anymore. Here's the thing. We are not done. Truly, like Kimberly, we've just started. All this isn't the number. This is the process. This is the process that we're going to go through and actually to find the slope of the tangent line. I'm going to want you guys to get some practice with this. But what I really care greatly about is that there is some level of understanding of where this formula is coming from. How are we feeling about where the formula is coming from? Okay? You could like go home tonight and have a great dinner conversation with mom and dad over it. But
We don't have
you would
dinner at the
teach them.
dinner table.
Okay, so here's the key. Here's the key now. Some of you guys are really good with this and you know exactly what to do. In order for me to find the slope of the tangent line at x equals 4, all I need to do is put it all together. Right? I've got to find the limit as x approaches 4. I need f of x. Do we know what f of x is?
Yes.
Yes.
For this particular problem, we know what f of x is. F of x is negative x squared plus 6x minus 1. It's f of x minus, now I need f of 4. Go find f of 4. Okay, maybe you get it right from the graph, you know that it's 7. I was surprised last class, the hardest thing we seemed to do, and I'm not picking on them, but it was a hot mess figuring out what f of 4 is. You could just plug it in and say it's negative 4 squared plus 6 times 4 minus 1 over x minus 4. Great. Right, that's the setup. And then from here, we're just going to let the math skills flow. I think most of you guys can finish this without me. And if that's you, finish it. Negative x squared plus 6x minus 1 minus, I need to evaluate all the stuff that's inside the parentheses. 4 squared is 16, but it's negative. Plus 24, I think that gets me to what, 8 minus 1, 7. Anybody surprised that f of 4 is 7? Why not? You can see from the graph, right? If x equals 4, the y value is 7. But if you couldn't tell from the graph, you plug it in. Over x minus 4. Okay, you could do limit as x approaches 4, negative x squared plus 6x minus 8 over x minus 4. The goal here is to evaluate the limit. We are pros when it comes to evaluating limits. What are we going to do?
Plug it in.
Okay, you could try plugging it in. I bet some of you are so good with evaluating limits that you probably already have a sense of it's not going to work. Right, we're going to get 0 over 0. So, right, you can like factor and cancel. You can do your x box. I realize the fact that there's a negative leading coefficient causes some problems for some folks. That's okay. Right, my advice for the folks that are going to get messed up by that negative, factor it out. Right, factor that negative 1 out in front first. So it's x squared minus 6x plus 8. In the bottom, it's x minus 4. We're going to get the limit as x approaches 4 of negative 1. X squared minus 6x plus 8. Trust your instincts here. You guys have been factoring stuff like this since algebra 1. This is not the thing I want to worry about right now. If you're getting 0 over 0 when you plug in 4, you've got a factor of x minus 4 in the denominator. Most likely, there's a factor of x minus 4 in the denominator as well, in the numerator as well. And so, for the folks that just factored it, we're getting x minus 4 times x minus 2. Okay, we're good. So, the x minus 4's cancel out. And we take the limit as x approaches 4 of negative 1 times x minus 2. When you plug it in, we get negative 1 times 4 minus 2, negative 2. Okay, that negative 2, what is that? That's the limit, but what is it really?
Slope.
This is, I heard it, this is
Slope.
slope. It's the slope of the tangent line. Look at that line. Is anybody surprised?
Nope.
Is anybody surprised that the slope is negative 2? Daisy, are you surprised by the negative?
No.
Why not?
Because it's decreasing.
the line is decreasing, right? If the line is decreasing, the slope has to be negative. I don't think, Anthony, I don't think you or anybody else in the room would look at that tangent line and say, oh yeah, clearly negative 2. But what I hope you'd say is, I know that that line has to have a negative slope. Negative what? You're going to have to go through this process. Now here's the thing. I know I keep making a big deal out of the conclusion. So here's what the final bit is going to say. What I want to see written down is this. I know that tan at x equals 4 is negative 2. What that tells me about the line is, what does it tell me about the tangent line? Jasmine.
That is decreasing?
That the tangent line is decreasing. Not only is the tangent line decreasing, the function is decreasing. So what I want to see is this tan at x equals 4 equals negative 2, and that is less than 0. Therefore, f of x is decreasing. Make sure your conclusion is not too strong. Because the slope of the tangent line is negative 2, that means the function is decreasing everywhere. Jennifer, where's it decreasing? At x equals 4. Questions before you guys get some practice from here?
So we label our tangent graph the same as our original graph?
Nope. What I'm saying is that f of x is the function is decreasing, and the tangent line is decreasing. Good question. Other questions before I give you guys some practice time? Okay. True or false? For this graph, tangent line is always going to be decreasing at all the points.
False.
False. Adriana, why is false?
Because on this side of the graph,
On this side of the graph,
the function of f of x is increasing.
the function of f of x is increasing, and so the slope of the tangent line is going to be positive. Okay, true or false? There is at least one point where the tangent line will be horizontal. True? Where? Let's get some answers. Where? Where's that tangent line going to be horizontal? Is it 1? Is it 2? Is it 3? Is it 4? Is it 5? Marvin, where's the tangent line going to be horizontal?
Where it changes from going up to going down.
Ah!
Oh no.
Again! I'm sorry, one more time.
I don't get it.
At x equals 3 because I heard him say the word
The slope?
it.
Slope.
Where is the tangent line going to be horizontal?
At x equals 3.
At x equals 3.
Because the slope goes from being positive.
The slope changes from being positive to being negative. I think I like that. I think there's a fancy word that we know for x equals 3.
Vertex.
It's a vertex, right? Because we're talking about a parabola. You can also call it a maximum. Like lots of options happening here. Good? All right, so here's what I want you to do. There is a table where we're going to summarize all of our findings here. And then you're going to get some practice. That was probably the longest part of what we're going to do today. Okay. So filling in the table, I'm going to assign you guys some points. We just did, was it x equals 4?
Yes.
Okay. Coordinates for the point of tangency were 4, 7. Behavior of f of x at this point.
Decreasing.
The graph was decreasing. The slope is negative 2. Now the equation for the tangent line, you guys know how to write equations of lines. There's two ways. You've got slope-intercept form, and then there's the point-slope form. I love point-slope. And for those of you that are like, wait a second, what's point-slope? Hold on, Ron Bear. Y equals x minus x1 plus y1. That's point-slope. That's the one that I want to see. Okay. And for the equation of the tangent line, I'm a big fan of using L of x. L for like tangent line. Okay. So although Lucio thinks it's L of x for him. So L of x is going to be, take my slope, negative 2, x minus 4 plus 7. Okay. So I've got 1, 2, 3, 4, 5, 6 groups of good-looking teenagers. Here we go. for Jasmine and Rambir, you guys are going to go through this whole process again for x equals -1 and x equals 5. Team Kimberly, x equals 0 and x equals 3. Team David, x equals 1 and x equals 6. Team Christian, x equals 2 and x equals -1. Team Anthony, don't ask me to repeat these, I won't remember. X equals 0 and x equals 5. Team Nora, x equals 2 and x equals 6. Did all the groups get 2? Did all the groups just get 2?
Yeah.
Jasmine and Rambir, you guys get 2?
We got
2,
-1
4,
and
5, 7, 8, 12. Perfect. Okay. So your goal, you have 7 minutes to find the slope of the tangent line, the equation of the tangent line, and the behavior of the graph at each of those 2 points. Strongly recommend that you make sure you get the setup right first, because if you get the setup right, everything's good. You can write anywhere that you need to. 7 minutes. Show me what you can do.
Hey, bro.
We have to do it on the same graph? Yeah. These are easy. You have to write like that. Oh.
So, what I'm saying is that x equals -1.
That 1, 5.
Is
Oh, yeah.
This is where you're going to draw the tangent line.
Oh, it depends on what the person
You don't have to draw all of the lines. All we're really interested in is the slope of the tangent. So if you're able to say, oh, I kind of get this guy here, and you know how to slope it. Okay, so what points did I give you guys? 1 and 6. 1 and 6. Okay. So I think it would be a good idea for you guys might want to say, we're going to do x equals 1, we're going to do x equals 6, and then kind of compare.
Staying the same. Yeah. It's for 3.
So for okay, so there's stuff here that I like to do.
So we follow the same equation, right? This would be as x approaches 0. The first one.
Show me your setup. Going. And writing annoying little brother, Jonathan. Good, good. Go.
Wait, we still use this, right?
Good, keep going. So can I see your setup? I just want to see this first equation. As many as x approaches 0. Good. And we're going to keep writing. Right, that makes Kimberly, can I see what you got?
Wait, which equation are we using?
Love it! Love it!
That's the equation.
What did you get? You can see what they are. Good. Good answer. Okay. Jasmine and Rambi, how are we doing? Limit of x equals -1, f of x minus 11. F of x minus that over that 11.
So then whatever f of 0 is right here, put that right here. Yes. Now it's y, right? What's x?
It will be x
Not
minus
y, it'll be
no,
-1.
it will be x.
No, it will be -0, right? But for that you have to plug it in.
But you have to put it.
Oh,
So
yeah. So it's still -1, right? Yeah, it's still -1.
So those will be 0 over 2.
Make sure you fill in the table. I want all the stuff.
Yeah, you are? Yeah. Just like regular sex.
Crystal?
Yeah. Yeah. That's 6 over 0.
6 over 0?
Yeah.
Did y'all factor out x?
Yes. Because you know that x minus 0, the 0 keeps to the bottom.
They left with 0.
Yeah, x minus 0 is just x. So, yeah, okay, you factor that out. The negative x,
Yeah.
when you plug in 0 will be 0. 0 plus 6.
You get it? Because x minus 0 is going to be 0 x.
So x, you subtract 0 then x.
So we don't plug in 0 for x.
Well, it's because you're subtracting it, and the equation is x minus. Because the equation here feels like you use the limit, right? So x minus 4. But since the limit, you go positive or negative 6, you have to plug in x on minus 0. So if you subtract x from 0 from x, it'll give you x.
Yes, sir.
Yeah? Okay. And like on the other one, he left it as x minus 4 because you can't.
Okay, 1 minute left. Alright, when I say calculus, you say ready? Calculus! Ready! Calculus! Ready! Okay, now here's the thing. I know some of your groups, some groups have already found slope of the tangent line and all that stuff for at least one of the points. And are working on a second point. The reason I gave all the groups 2 different points is so that we could get a complete table of values and we've got some checks. So some brave soul, get me started. Tell me your point. David, give me what point?
X equals 1.
X equals 1. So what are the coordinates?
1, 4.
Okay, 1, comma 4. I think I like that. And the behavior of f of x? Increasing. Okay. Slope?
4.
Positive or negative?
Positive.
Positive. And can you give me the equation of your tangent line?
L of x.
L of x
Equals 4.
4.
Parentheses x minus 1
Yep. Okay. What? Okay. Oh, and only one group had x equals 1. Okay. Another group. What'd you get? Take me through all your stuff here. Nora.
For x equals 2, we got the coordinates of 2, 7.
2, 7. I think I like that.
And the behavior of f at this point was increasing.
We're increasing at this point. The slope?
The slope is 2.
Slope is positive 2. The equation?
L of x
L of x.
equals 2.
Yep.
Times parentheses x minus 2.
Yep.
Plus 7.
Love it. Some other groups. What else is out there? Jonathan. At x equals 0? 0, comma, -1 behavior. Increasing slope. Positive 6 equation. Okay, -1. Other groups, Marvin.
-1, it's one is -1, -8.
-1, -8.
Increase.
Sorry, I just got distracted by your antenna. Okay, -1, -8. Behavior, we are increasing. Slope,
8.
positive 8. Equation of the line.
8, x minus 1 minus 8.
Okay, I'm going to pretend that what you said was L of x equals 8
Times x minus 1
times x minus 1
minus 8.
minus 8. I don't know that I love that. I don't know that I love this one. I want to. It's +1, right? Because it's x minus that x value. Okay, how about x equals 3, x equals 5, and x equals 6? They've got to be out there somewhere. It's okay. Okay, Jose, what do you got for me?
For the sixth one, the behavior.
What's the y coordinate?
Oh, -1.
6, comma, -1. I agree. Yep. Behavior? Decreasing slope. -6. Nicely done.
And L of x equals -6 parentheses x minus 6.
Yep.
Is plus -1.
Plus -1, or since we're all friends, I'm just going to say -1. Okay, now what we're missing are x equals 3 and x equals 5. Rambir.
So for 5, we got a point 5, 4.
5, comma 4.
And then it was decreasing at this point.
Decreasing.
With the -4 slope.
Slope is -4.
So L of x equals -4 x minus 5 plus 4.
L of x equals -4, x minus 5 plus 4. Love it. Okay, how about x equals 3? Let's see if we can just do this. Look at the graph. Look at the graph. Coordinates of point. We're at the vertex. Those coordinates are 3, 8. Okay, we're at the vertex. The slope there. Draw on your tangent line. What's the slope there? 0. L of x is equal to 0. X minus 3 plus 8. Or you can L of x is equal to 8. Absolutely. Okay. 1 minute. I want you to look at this table. I want you to think like a mathematician. Look for the patterns. There is a reason that we have spent all this time. There are some connections that I want you to point out to the whole group. 1 minute. Go for it.
They're all the same. Like, not the same, but like, they're all reciprocals, right? No. Same number, but because why? Because it's a parabola. There you go. Girl.
Careful, I can play the video back whenever I want to.
I could play my picture.
Oh, no.
Oh, the one with the head massager?
Okay, I'm looking for the pattern. groups have found at least 2 patterns going on this table. At least 2 patterns. I see Noemi, I see Rambir, I see Giselle, I see Jasmine. How about ladies back over there? Any patterns? See some patterns? Okay, Kimberly, give me one of the patterns that you see.
We said that as it's going up, you see positive numbers and then it's going negative. It's the same numbers,
Yeah.
but it just flips them. One is positive.
Okay, so I heard you saying a couple of different things there. I heard you say like when it's going up, and you lost me on the it. What's the it?
Function.
When the function's going up, okay? What's happening?
It's increasing, like the numbers.
Oh, there was that it again.
No, the numbers stay positive.
The numbers stay positive, like the slope numbers?
Yes.
Okay, so I want you to be really, really, really specific. As the x values are increasing, what happens to the slope?
The slope numbers stay positive.
The slope numbers stay positive forever?
No. There's a point where it changes.
There's a point where the slope numbers change from being positive to being negative. Where does that happen, Kimberly?
At 3.
At x equals 3. Okay, other patterns. Take anything from anybody. Oh, so sad.
Oh,
Edgar.
At the number, well, the behavior at x approaching the vertex.
Okay, as the x values are approaching the vertex, the function's increasing. Like as you're getting closer to the vertex from the left, the function's increasing. We're okay. And then after that, we're decreasing. Okay. Anything else? Robert?
Is there a pattern with the exponent value and the slope?
Is there a pattern with the exponent value and the slope? Oh, you guys are waiting for me to tell you.
No, there is a pattern.
There is a pattern.
What can you say?
What is the pattern? Is there a pattern there? Look at the x values. Look at the slopes. I won't tell you. I want you to see it.
Get factors.
Maybe it's helpful. Cover it up if you can so that all you see are the x values and the slopes. Look at the x values, look at the slope. Not really sure what I'm trying to do there with my ruler. X equals -1, the slope is 8. X equals 0, the slope is positive 6. X equals 1, the slope is 4. The x values are increasing by 1. And the slope
Down by 2.
is decreasing by 2. Every time the x value increases by 1, the slope is decreasing by 2. What kind of pattern?
Correlation.
No.
Well, you're talking
I heard it. What was it? It's a, one more time, Jose? It's a linear pattern. It's the pattern of a line. Whenever the x values increase by 1, the slope decreases by 2. You could also get fancy and say it's an arithmetic pattern. Rambir.
You see, what I was talking about is because the equation is an x squared equation.
Yep.
So if this was like an x cubed with these numbers going down by 3.
Possibly. We'll talk more tomorrow. All right, we've got 10 minutes. This is perfect timing. It's almost like I had a plan. Okay, I want to push your thinking a little bit more. And the way I want to push is we're going to go into the land of the piecewise functions. It's fine, Edgar, just breathe. Just breathe. You can't hate piecewise functions. Piecewise functions are fabulous. Now, here's what I know. I know some of you, your math skills are really strong and you do not need me for this. Fabulous, but stay with me just for this first minute. I've got this piecewise function f of x, and part A says determine the value of tan. Tan at x equals 2. Then using this information, describe the behavior of f of x. I'll tell you, when a question like this shows up on like the unit test or the trimester exam, usually the first point comes from, do you even know how to start? So, have a quick conversation with somebody near you. What's your start? How are you going to find tan at x equals 2? I'm looking for a formula. I'm looking for an equation. How are you going to start? Okay, I've seen it on at least 3
So whenever we see d10 of x it always means to find the slope.
It means to find the slope of the tangent line. Alright, I've seen enough folks papers that I'm satisfied here. Slope of tangent line at x equals 2 involves a limit. Slope of tangent line is always going to involve a limit. It's going to be the limit as x approaches 2. F of x minus f of 2 over x minus 2. It is that same setup from before. Right, the issue now is, well, what's the function? Right, what specific function are we going to work with here?
The piecewise.
Clearly it's going to be the piecewise, and really it depends on what is the x value that I'm interested in. If I'm getting close to 2, like limit close to 2, do I use the top function or do I use the second one?
Second one.
Clearly it has to be the second one, or I hope it's clear. Right, the x values are getting close to 2. My x values are going to have to be bigger than 0. So then I'm going to say it's f of x, so what is that? Square root of x plus 2 plus 5 minus, now I need to find f of 2. F of 2, if you can do it in your head, great. Or plug it in. Getting there for sure qualifies you for the first point.
Yay!
Okay? So I've got the limit as x approaches 2. Square root of x plus 2 plus 5 minus, what is that? 2 plus 2 is 4. Square root of 4 is 2 plus 5 is 7. Over x minus 2. And I'm just going to combine that and say it's minus 2. Okay. At this point, you've done the new stuff. You're not done with the problem, but you're done with the new stuff. Just quick show of hands. How many of you guys are pretty sure you know how you're going to go about evaluating this limit? You don't know what the answer is, but you know your next move. Okay, go for it. Just go for it. I want to talk to anybody and everybody who's like, I'm really not sure right now. Where are those folks? Kind of not sure. Okay, if you tried plugging it in, you're going to get 0 over 0. You're going to get the indeterminate form. That should not be a surprise. Right? Because I'm going to get square root of 4 minus 2 over 2 minus 2, 0 over 0. Folks that know what you're doing, just keep going. You're getting 0 over 0, the indeterminate form, so I need something clever. Jennifer, do you see something clever we can do here? And if you're not sure, you're not sure. That's okay. Okay, sounds like we're not sure. Kimberly, what do you thought?
Fancy one.
Okay, tell me more about this fancy one.
So the square root of x plus 2 minus 2, we're going to multiply both by the opposite, so the square root of x plus 2.
Okay, I heard you say opposite, but it's not opposite. That's not the word. The square root of x plus 2 minus 2, the thing that you're really looking to multiply by is
Conjugate.
conjugate. Okay? Kimberly, were you going to say multiply by square root of x plus 2 and square root of x plus... I was sure you were going to write the right thing, but you called it the wrong thing. It's just the conjugate. Right here.
We don't put the sign inside the radical?
No, it's the sign outside of the radical that changes. I promise. Okay. Now, here's what I know from like checking your homework. A lot of you all know why we multiply by the conjugate. You know the secret multiplication that's going to happen, and you don't show the box. And that's okay. But I think there are still some folks in the room that maybe aren't 100%. So let's do it. I'm just going to go over here on the side. So let's do the box. I've got square root of x plus 2 plus 2. Square root of x plus 2 minus 2. First box in the array model, square root of x plus 2 times square root of x plus 2. X plus 2. Over here. 2 square roots of x plus 2 down here. But now it's negative 2 square roots of x plus 2, and then over here? Negative 4. The reason that you multiply by the conjugate these guys over here are always going to add up to 0. Always. And so the pattern that a lot of you all have noticed is that when you multiply by the conjugate, what happens is this guy here squared minus this guy squared. In the box, I can see it, x plus 2 minus 4. We know how to reduce that. How about x minus 2? X minus 2 in the numerator. I've got an x minus 2 in the denominator. Those I can cancel out. And I'm going to find that limit as x approaches 2, 1 over the square root of x plus 2 plus 2. Hold on. Marty, are you okay over there? You've been really quiet. I'm worried. Okay. The limit as x approaches 2. This is these are. You're just going to evaluate. You're going to plug it in. Hold on, Robert. Should be 1/4. And here's the folks that went solo. I'm going to be on to 1/4. 2 people. 3 people. Ron Beer, what's your question?
What happened to the 4?
What happened to the 4?
To the negative 4?
Okay, so the only thing that survives in the multiplication is the x plus 2 and the minus 4, right?
Well, when multiplied by conjugate, with the negative 4, so it should be...
Just ignore him. Negative 2 times 2 is going to be negative 4. I've got x plus 2 minus 4. Combine like terms.
Okay.
Adriana, what's up? Okay. Is everybody good with the 1/4? Jennifer, you okay? Okay. The 1/4 represents what? I want to see 10 people. 10 people that can tell me what the 1/4 represents. I see 1, I see 2, I see 3, I see 4, I see 5, 6, 7, 8, 9, 10. Jennifer, what does it represent? Be more specific. Slope where? Okay, it's the slope of the tangent line at x equals 2 is 1/4. What does that tell you? 10 other people. What does it tell you? What does it tell you? I see 1, I see 2, I see 3, I see 4, I see 5, I see 6, I see 7. Daisy, what does it tell you?
It's increasing.
Ah!
Why you say 8?
Again, girl, you said it. This is greater than 0, therefore what?
The slope of as the function increases by a slope of 1/4.
Okay, hold on. F of x, the function, what's it doing?
Increasing.
Is increasing. Don't tell me stuff that you're not sure about. F of x is increasing. Where? At x equals 2. Okay, so real quick, homework tonight. Okay, homework tonight should be relatively straightforward. You're just going to get some practice with finding slope of tangent line and tell me what it is. It's on the last page, right? There's 5 problems on the back. I want you to pick 3 of them. Hold on, Jose. One of them must be number 5. Okay, number 5 is calculator active. The reason why number 5 is calculator active is at some point you're going to get to some limit expression that is giving you 0 over 0, and you will have no idea how to find that limit. You have your calculator. What are we going to do?
Plug it in and find values.
I'm glad, Jose, you're going to use it. You're going to build a table of values. You're going to show me that table of values. For those of you that are staying to work on the problem set, we're going to start at 4:15. I need to go take care of some stuff. We need to